Welcome to the Business District. This is an activity that I've created for some high school 10th grade mathematics students. They will be working with businesses and their growth. So I've set up these information walls, I guess. So here's the basic wall that gives them the initial information overall. The class will be divided into two groups, and then each group will then subdivide to accomplish each part of the task. And their task is to create warehouse space to handle their business's growth. So they're going to be building 5 different buildings. They need to be wise in their use of land. So they need to pick a plot spot size that best fits the size of building that they're going to need to build, so that they're not spending too much. They also need to make sure they build the building so that in its growth it can cover that cost of the building. So they need to be thinking about that. I'm not giving them all the costs of the building and the costs of the land. At this stage of their learning, that would be a little overwhelming for many of the students. Right now they're just focusing on recognizing a growth pattern and then being able to use that growth pattern to predict the future growth pattern, and then be able to make wise decisions about the size of the housing or building structures that they need to build. They will be, since moving is expensive, they're going to build for every 2 years of growth. So the growth is exponential, and that growth will be significant enough that they're not going to be able to stay in that building for a long period of time for more than 2 years. At least that's kind of how I set up the scenario. One is more higher in their growth than the other, and I set them up to have some great discussions about the differences between the two, and to think about how much more the growth is in one over the other, and why I made some changes. So the first business is an energy bar business, and I start off giving them the scale. So the scale is 1 block equals 5 feet, and that's 5 feet each direction, so 125 cubic feet, or 25 square feet. 1 block can store 1,000 units, which is 1,000 energy bars. So they'll take that into consideration as they look at the growth. So I've given them the growth, which is for these 0 years, they were just working on producing 1 unit that they were confident that was really an energy bar that was something amazing. The second year, they're producing 5 units, so they're still tweaking them and growing a little bit, but not much. I mean, the first year. The second year, they've produced 25 units, so the growth seems like it's really pretty small, but it gets really large really fast. So they're not going to start building their buildings until it's year 6. So they're going to have to figure out how many units are there in year 6, and what size of building would we need to build to start at year 6, and then they'll need to build year 8 and the year 10 and 12 and 14, because they're going to build 5 buildings. So the class will each be this group. Half of the class will be in this group, and they will divide up to build these buildings. And so, move over just a little bit. So growth at this rate is through year 10. Then it got too large, and it's really not reasonable. So that's hopefully part of the discussion we're going to have, is that kind of exponential growth isn't sustainable for a long period of time. And so I've limited it on growth. On year 11, the growth becomes constant. So it changes from an exponential equation to a linear equation at a constant rate of 100,000 energy bars a year. So they will need to make those adjustments, and that will push that group quite a bit to handle those 2. But it also gives them a break on the size, so they're not having to build these huge structures that will take more time than I want to have them take during class. The other team is going to do, in our class for our expedition for the semester, we've been studying, we've done some research on furniture and innovative educational furniture and classrooms, and what makes an innovative classroom work, what kind of furniture supports learning and growth, and some of the challenges with the kinds of furniture that we have, that they're in these hard chairs and they can't sit for a very long time. So they will be designing and then building cardboard furniture. So this kind of fits with what we've been doing. So they're going to have this company. Their scale is the same, 1 block equals 5 feet, but each block only stores 10 units. So they can't fit as many pieces of furniture in the same space, which makes sense. They're going to start building at year 8. And their growth will continue through the 16 years. Because their growth is a little slower, they start year 1 at 2 units, and then year 3 at 8 units, and year 5 at 32 units. So I purposely, since theirs is just a doubling, I left out, I only put in every other year so that it was a little bit more challenging for them to figure out their growth. But they should be able to do that. But because it's only doubling, they can handle that rate in terms of the size of buildings that they would need to build over the 16 years. So they'll have that information to go by, and then it's from then on, once we say go, it's kind of a free-for-all where they get to decide where they're going to build, and they have to work together and talk with the other team. We'll kind of see how that goes. I've created plots of land that are just different colors, and they'll have to go pick those plots and decide where they're going to put their buildings. We've got a road, and then I've given them an example building that they can use. It's huge. It is beyond what the scope of what they're going to need to build. At first I was thinking they would have to build something this size, and then I scaled it down because it just took a lot longer than I wanted, but they could recognize that it needs to look pretty nice, but also needs to have the features of a warehouse. It could be office space, but then also bays for loading and unloading. One of the things that we will discuss is some of the, if they were doing this in real life, what kind of changes would they have to consider. And so I'm going to switch to my other screen where I have some debrief questions. And this is for me, in the way that I teach and the way that we do things at our school, the debrief. We do a lot of team building, and so debrief is really important. Now you've had the experience, let's talk about it. So how did you decide the size of your building that you needed to build? So I want to have them go through the mathematics that they did and the thinking that they did to decide how, the basic foundational square footages and measurements, as well as the height. What challenges did they face? There'll be various different challenges they face. We want to go over those. And this is where I hope to have, in this third question, a lot of discussion. If you were actually responsible for building to keep up with the growth of a business, what other considerations would you need to evaluate? One of the things that I learned, and I toyed with having the kids have to live with that limitation, is that the cities have a height restriction, and it's usually 40 to 50 feet high in an industrial building. You can get an exception of up to 65 at times, but that definitely, height is a cheaper way to go because you're not using land as much. And that's the discussion I hope to be able to have with the students, is really what kinds of things do they need to consider so they get the scope of the different mathematics that they would need to do, the pricing of the land, the cost of building the building, and so that they, in Minecraft, that's you have free access to whatever in the creative mode, so you really don't have to earn it or work to get all the things that you need to build the buildings, and I wanted to pull back the costs of doing that. So then I wanted to compare the two different scenarios. Why did they think they were different? The fact that one had a cap and then it shifted to a constant rate of growth, the other one didn't, and so just talking about, did they seem realistic? Could between energy bars and furniture. Where do they think the furniture cap would take, and then it would stop growing as much? Everybody gets excited about exponential growth, but how long does exponential growth really last? Would it really last the 10 years that I said in that first scenario, or would it cap a little bit earlier? So those are the discussions I hope to have, and I think it'll be a fun activity and push them to do more math in different ways than they have. Hope you enjoyed the lesson.